Hey guys, welcome to Unit 3, Lesson 6. My topic today is proving trigonometric identities. So let's get started with the warm-up. Pause the video and try it. The warm-up says if x equals 5 pi over 6, show that. Whenever we talk about show that, remember you pick one side and make it look like the other. Or maybe you simplify either side so you don't move things from one side to the other. That's the whole idea. So I'm going to take the left side that looks more complicated and I'm going to make it look like the right side. For that, I need to first substitute my x with what? 5 pi over 6 tangent square 5 pi over 6 plus secant square 5 pi over 6, right? Equals secant fourth to the 5 pi over 6. First of all, 5 pi over 6 is what? In the second quadrant, right? We are in the second quadrant. And my secant 5 pi over 6. Let's find that down. The value for secant 5 pi over 6. What is reciprocal of secant? It is cosine. So find me cosine 5 pi over 6, which is in the second quadrant, cosine is negative. Oops. Cosine is negative, so it's going to be negative rad 3 over 2. And if you flip it, it's going to be negative 2 rad 3 over 3. Or you can even leave it as negative 2 over rad 3. It's fine because you're going to square everything, so it'll break it out. So I'm going to actually use, for this time, I'm going to use 2 over negative 2 over rad 3. This is what I'm going to use. These two are same. It's just that since they're all squared, I see that secant is squared, tangent is squared, everything is squared. I can do that. Also, let's find out the value for tangent 5 pi over 6. Again, in the second quadrant, tangent is going to be negative, and it is rad 3 over 3, right? So now all you do is substitute the values. Secant square 5 pi over 6 is negative 2 over rad 3. It won't matter whether you use 2 rad 3 over 3. I'm saying that again. And then tangent, it's multiplication between them. Negative rad 3 over 3 squared plus negative 2 over rad 3 squared equals negative 2 over rad 3 to the 4th. Now just simplify this. This would be what? 4 over 3 times 3 over 9, right? Plus 4 over 3. You simplify this. This cancels. You're left with 4 ninths. 4 ninths plus 4 thirds, we'll do that, is actually 16 ninths. And this side is what? 16 over 9, which is, so it said show that this is true. Okay, so let's get started with proving trig identities. See if you can do the fill in the blanks, or I'm going to do them with you. So remember, an identity is an equation that is true for all defined values of a variable. We are going to use the identities that we have already established to prove or establish other identities. So we learned a few identities in our last lesson also. So that would be a good idea to have them in front of you while you're doing these questions. So let's do the blanks. Guidelines for proving verifying identities. Start with the most complicated. And I said that above too. Side of the equation. Factor an expression, add fractions. Each question will be different, right? Square a binomial or create a monomial. Denominator if possible. Use the fundamental identities. And convert all terms to sines and cosines. It's so much easier to turn them into sine and cosine and then try to solve these questions. Always try something, even if you hit the dead end. 1. it says prove this is equal to that. So I'm going to take the left side and I'm going to try to prove it like the right side. So again, try to write everything in terms of sine and cosine. Cotangent square x is same thing as cosine square x over sine square x, right? Minus cosine square x. I have fractions. What do? Take the LCM, so I get sine square x. My first term stays the same because I'm multiplying just by 1 here. And on this side, I'm multiplying by sine square x and sine square x, right? Minus cosine square x times sine square x. Now in the numerator, if you see, you can factor out the cosine square x. And you're left with 1 minus sine square x. And you have just sine square x in the denominator. What is 1 minus sine square x? Same thing as it is. Same thing as cosine square. So I have this cosine square, and in place of that 1 minus sine square, I wrote another cosine square x over sine square x. And keep checking what is going on. So look here. Isn't cosine square over sine square x just cotangent square x is equal to, oh sorry, not equal to, my bad. That's cotangent square x times times cosine square x, and that's your left side, and you proved it, right? So let's try example 2. I know they look a little difficult, but if you go along, try to, I always say, pick the complicated side, substitute with sine and cosine. So here again, I see cosecant, secant, I see sum of sine, cosine. I'm going to work with the left side. If you choose to do the right side, go for it. But for me, left side is coming more obvious, so I'm going to do that. So the cosecant can be written as, let me zoom in, 1 over sine x plus 1 over cosine x, and then what am I left with here? Sine x plus cosine x, right? Take the LCM of this whole thing. If I do that, it is cosine x plus sine x over sine x cosine x, right? And now all over what? Sine x plus cosine x. Do your keep change flip? What do I get? Cosine x. I'm just going to change colors because I feel like it'll look so much better than you're able to do this. So cosine x plus sine x over sine x times cosine x times, this would be what? 1 over sine x plus cosine x. These cancel out, and you're left with what? 1 over sine x, 1 over, and we're nowhere close to it, and you're like thinking, what's going on here, right? Isn't 1 same thing as sine square x plus cosine square x over sine x? I'm going to actually write them separately. So it'll be sine, this is sine x. So I substituted 1 with sine square x, cosine square x, and I'm going to set up 2 separate fractions. So that's what I'm trying to do. Sine x, cosine x, and here also sine x, cosine x. What happens to your sines? This sine and square cancel out, cosine and square cancel out. So you're left with sine x over cosine x plus cosine x over sine x. What is sine x over cosine x? It is tangent x plus and cosine over sine is cotangent x. Now addition is commutative, so switch them back, and that is it. That's how you do it. I know this was a little intense, but you have to just see, always see, because when I got to this step here, I couldn't really see how am I going to get my cotangent here when I'm left with sine and cosine, right? And then substitute one can I substitute? Think about it. What is 1 equal to? And that's where it came from, that it's equal to sine squared x plus cosine squared x, the Pythagorean identity. Anyways, try